Dear students, today in this session, I will tell you how to measure voltage, current, and calculate effective resistance of a series connected resistors. So, before performing experiment, you should know the basics of the breadboard. Like in previous video, I have explained you the basics of breadboard. Bottom side open ಮಾಡಿದ್ದೆ. So these two are for upper session and lower session are for connecting power rails, that is for connecting power supply or ground, and these are for connecting components. So these are sorted vertically. These 5 slots are connected, next 5 slots are connected, this slot and this slots are not connected. Individual slots are not connected to each other. Vertical ಈ ಥರ ಕನೆಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಕೆಳಗಡೆ ಕೂಡ ಇದೇ ಥರ ಇವು 5 ಏನು ಸ್ಲಾಟ್ಸ್ ಇದಾವೆ ಇವು ಕನೆಕ್ಟ್ ಆಗಿದೆ. ಇಟ್ ಈಸ್ ನಾಟ್ ಕನೆಕ್ಟೆಡ್ ಟು ಅಡ್ಜಸೆಂಟ್ ಲೈನ್. ಓಕೆ, ಸೊ ಕಮಿಂಗ್ ಟು ಅವರ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್, basic series inverter, basic connection of resistors in series. So let us say I have 3 resistors and it is connected to a battery. Okay, so this is R1, R2, R3. This is how resistors are connected in series. This is one resistor, this is another resistor, and this is third resistor. Connect them in series and then connect the battery. To find out the current, what you have to do, you have to insert an ammeter, let us say at this point. So I will tell you how to make a connection for this and measure the current. To measure voltage, connect your multimeter to these 2 points, let us say point A and point B. First I will tell you, just check one simple resistor. So this is a resistor which is of 1K. So how you have to make a connection? Don't connect in same slot, connect it to different slot. Okay, this is full entire line is shorted, so connect one end here, connect another end here. Then make a connection, that is supply. So this is a dual power supply which supplies the DC voltage. So positive of the supply connected to one slot and negative of the supply so positive of the supply connected to one slot on a breadboard, negative connected to another end of the resistor. Now you want to find out what is the current through this resistor of 1K. What we have done, we have given a 5 volt DC supply which is connected to resistor. Okay, now I want to find what will be the current through this resistor. So to measure that, on a multimeter, switch on the multimeter, keep this knob on a DC voltage, should point towards this DC line. Then connect your probes, one end here and another end here. So I am measuring current, so it should be connected to milliammeter mode. Connect your probe, one end here and one end here. See, you can see it is displaying 5.10 milliamp. So what was the current you got? So I is equal to 5.10 milliamp. Now let us calculate current. That is our current from this equation, which I is equal to V by R. What is the supply we have given? It is 5 volt. Then what is the resistance? It is 1 kilo ohm. So it is current will be 5 into 10 raised to minus 3 amp. So that is equal to 5 milliamp. So this theoretical value is matching with the practical value. This is with a single resistor. Now to calculate current through the resistors, 3 resistors which are connected in series, what you have to do? What are the changes you have to make? Take 2 more resistors. So remove this battery connection. Connect according to the circuit diagram. So let us say this is the resistor which is already connected. I have to connect one more resistor. So while making connection, make sure that you connect them in one slot. If you by mistake connect this resistor to this slot, they are not connected. There is no contact between them. Then connect one more resistor. So connect on the same slot so that both the ends are connected. This is our third resistor. Now what connection is this? You have connected this one, this resistor as well as this resistor. Okay, to make a emitter connection, positive of this connected to another slot. Okay, then to measure the voltage, to measure the current, set this to milliammeter mode so that we can make the measurement of the current. Then place the ends, one end here, probe and see what is the value for the current you are getting. It is 1.74 milliamp. So let us note down that. So for 3 resistor you got a value 1.74 milliamp. Here I have used R1 as 1K, R2 as 1K, 1 kilo ohm. Same value, that is R3 also 1 kilo ohm. Now the total resistance, if they are in series, equivalent resistance becomes R1 plus R2 plus R3. So 1 plus 1 plus 1, it is 3 kilo ohm. Now let us find out what is the current. So with the formula, I is equal to supplied voltage divided by equivalent resistance. Now what is the equivalent resistance and what is the voltage? Voltage is given as 5 volt and resistance we have calculated it as 3K. So substitute here 3 kilo ohm. So it is like 5 by 3 into 10 raised to 3. If this 10 raised to 3 goes up, it becomes 5 into 10 raised to minus 3 by 3. This becomes approximately 1.6. You do the calculation, 1.6 something into 10 raised to minus 3, which is milli, and since it is a current, it is milliamp. So this is the value you got with the calculation. That is the theoretical value. And what was the practical value? So this was the value we got on a multimeter. So this is how you check the current through the series connected resistors. Then how to check the voltage? So voltage you have to check across the resistance from this end to this end and change the mode on the multimeter. So this becomes like you have to connect end to end. See what is the voltage? It is 5 volt. This is how you perform an experiment to measure current and voltage through a series connected resistor. Thank you for watching.